Zhang from IBM and Philip Reyes from iNEMI. So today they will give the briefing of this project and share what we will cover for this work. Okay, just briefly about the agenda. I hope you. Okay, I hope you all can see my screen. Okay, so I will briefly introduce the chairs, then talk about how iNEMI project is organized, the development process. Then Wei and Philip will brief the project, and I will explain how to join, and then we will have the Q&A at the end. Okay. So Wei Zhang is from IBM. He is now the senior supply chain engineer. He has been in the electronics industry for over 20 years, from the manufacturing engineering to the technology qualification. In the recent years, he has been involved in the smart manufacturing, also worked on the AOI, the test inspection, etc. Yeah, he has a number of publications and patents. Okay. Philip is from iNEMI. It's a EMS company, headquartered in the Philippines. Yeah, certainly the manufacturing and R&D team in global wise. Okay, he's now the China regional engineering head on the industrial excellence and engineering. Okay, so Philip has over 24 years experience in the electronics industry, especially on the manufacturing, the process development, equipment, the NPI, the advanced manufacturing, and also the lean technology, etc. So as iNEMI has quite an amount of services for the automotive electronics. So Philip has a lot of experience there as well. Just to briefly introduce the chairs, it's good that we have the leadership from the industry, and hopefully we have some others can join the project to make it an exciting project and bring value to the industry. So for the iNEMI project, we have several steps to identify the topics and to define the plan, the project. So now we are in step 4. We call it a launch. It means that the plan has been approved by the iNEMI technical committee. We have 2 documents. I will briefly show it in this webinar. In fact, Wei and Philip will talk about mainly about the SOW. Okay. So the concept is proposed to the iNEMI technology integration group. We call it a TAKE. They review and prioritize those ideas for projects. Then we select some topics that has high interest and important for the industry. Then we enter a definition to define the scope of the project, what we want to accomplish, the expected outputs. Then in the planning, it's really to develop the plan, develop the SOW, get into the details on the schedule, the tasks, resource would be needed. Then with the plan established, then we can start, confirm who would be the participating member. That's where we stand for the launch. iNEMI is an industry-led consortium. So every project, NEMI members can choose and decide they want which project they join. And also for the launch, it's open for the industry. The webinar is open for the industry as well to communicate and identify who would be the interested party to join the project. So that's the purpose of this launch phase. Also, as a consortium organized the project, we have the project statement agreement to sign. It defines the resource, the legal terms, and the data management rules, project policies, etc. So that the participating members need to agree upon to commit they will comply with those rules and support the projects participating in activities or accomplish some of the tasks. Okay, that's where we stand. So for the launch phase, it's really to commit the resource and confirm the project team. So after the launch phase, the sign up, we will enter the execution to accomplish the project plan. And then at the end of the project, we will have a closure to report what has been achieved and what's learning. And some of them will publish results in conference, or we organize end of project webinars to share with the industry. Okay. So for the initiative, we say for the planning phase, it's open for the industry inputs. In fact, a number of companies involved in the project planning. Then after launch, because we have information will be shared or discussed in the project will generate some results. So this will be limited to the committed members. It means that who signed the project statement. Okay. So I just mentioned the two documents we have. It's the governing documents for every project of iNEMI. So the SOW defines the scope, the background, what's the purpose, benefits, etc. The schedule. We will cover that in this presentation. The project statements I will show at the end when we talk about how to sign up. I will give you some idea what is inside the project statement. Okay, it basically defines the resource and time contributions. Okay. For this project, we have the requirement for the iNEMI membership. If you are already a member, you can just sign the project statement. Then if you are not a member, in fact, for this project, we define it as a faster turnaround project. It opens up for some non-iNEMI members if they have not made a decision to join the membership, but they are interested to join this project. It's more like a test water, and but this is only limited to one project. So there are some terms also defined. We have the MOU need to be signed also together with the project statement. I will explain that later when we talk about joining. Okay. So with that, I will turn over to Wei to start the project briefing.
Yeah. Okay. So Haley, can you hear me?
Yes.
Yeah.
Go ahead.
Hey, good morning, good evening, everyone. So today, Philip and I will just share this project briefing to you, right? So Haley, just let me know when we turn to Philip, right? So I will cover the first section.
Okay.
Yeah. Okay. So I will start from my side. Yeah. This slide is for the project background. As you can see, our project title, right? The AI enhancement for the AOI. So first, let's look at the background for our existing AOI technology, which is not new to the industry. has been, in the market for over decades, right? So widely used. And so you can see some of the list here for the defect detection, right? For the in terms of the quality requirement, misalignment, solder short, solder open body marking, right? So you can see some example image, right? So in the bottom here, so which is collected in the real production, right? From our information. And I think it's commonly known for the challenge in AOI, so including if you look at the performance, the false core, right, challenge and escape challenge in the production and quality perspective, and the challenge from the product complexity, right, the bigger, smaller components and the mix and all those shadow effects, right, etc. And also we know the project of the reason of this project is driven also by the newly emerging AI technology available, right? And we can see that there has been quite a lot of the AI model which has sufficient accuracy and the efficiency to help us to break through the boundary. We will say the technology boundary for the existing AOI technology. Yeah. So that's why we formed this project, and we will try to see how we can utilize this AI technique to to help us in terms of improving the performance of AOI. Okay, next slide, please. Yeah. So I think the objective, right? So again, as I mentioned, we will establish a common performance matrix. So we have some explanation for the performance matrix in order to evaluate the AI value add, right, to this existing AOI machine process in order to provide recommendations to the industry, right, for the future improvement opportunity. Yeah, we know the AI is new, right? It's hot and it's new, right? So how we can play around the AI for the AOI area, and hopefully we can get some lesson as Haley mentioned about the iNEMI project, right? This is one of our targets to gain some lesson and gain some experience on how to apply the AI, what's the challenge, what's the obstacle, right? Things like that. So the chart in the bottom is just to give you an explanation for how we are going to play the AI, right? So if you look at the existing process, typically we have the two steps in the left side, right? Two steps. AOI generate the images whether pass or fail, and then if for the fail image, it will be sent to the operator for the second step, manual judgment, right? Accordingly, we get the pass or fail result accordingly. And this is the traditional way, right, for the AOI process. And for the right side, this is we call the 3 steps process with the AI in place, cut in between the AOI and the operator process. So we call it step 2, right? So you can see basically the failed image from AOI will be sent to the AI. And then the AI will help to filter those failed image, and if the AI process still say it's a fail, then those failed image will be sent to the operator for the manual judgment. So we just cut in the AI in between, right? So we will see how this kind of process will be used and how for the overall performance. Of course, this is just a reference example, right, for how we play around the AI. And I think we have some prior discussion during the project team. And so this just for the team reference, if you're going to participate, right? So this is one of our reference solutions here, yeah, using the AI. Okay. So the project scope, right? So first we will investigate the existing and emerging AOI and AI technology status. So that means we may have some survey, right, to the companies using own the AOI and also the AI solutions. So what is the current status? Maybe some AOI company they have some sort of new solutions in the market, right? So hopefully we can invite them to play with us, and also we will identify the major applications and challenges for PCBA inspection. Typically we have some kind of the survey and questionnaire sent to those company and player to see what's their feedback, and then we will have some summary and definition for this project accordingly, right? And also we establish the common language and performance evaluation metrics for the AI and AOI. So different company may have different operational management KPI, right, for this AOI process. So if we apply the AI, so what would be the new KPI and performance index, right? So we are going to study this and try to understand and hopefully to establish a common language or kind of standard, right, for this field. And then establish the test vehicle for performance evaluation. This is, I would say, kind of a challenge as well, because the test vehicle here is not similar to the traditional test vehicle, like for a soldering reliability performance, a new no-temp solder kind of test vehicle, right? So the test vehicle here is represent for the we say the golden sample, right? Golden sample with all those kind of AOI defects on this test vehicle, right? So we want to create this kind of test vehicle and so that we can evaluate what is the overall performance from the AI plus AOI solution, right? So this kind of some tricky, and we want to make sure the team understand this, and we are going to also have a team discussion and see how we form this test vehicle, including what is the defect types, what is the coverage we want to see on this kind, right, on this kind of test vehicles. Yeah. And next, we're going to conduct experiment, right, in order to see the KPI, right? Of course, we need to conduct and run a couple rounds of experiment to evaluate this existing and emerging AOI plus AI solution and capability, right? So where to conduct the experiment, how to define the process flow, and how to do the data analytics. All of those we need to consider in the scope of this project, right? And also eventually after we collect play the experiment, collect the data, we report on what we found, right? And so what is the AOI plus AI landscape, and what is the result, and what is our recommendation, right, for the future implementation from such kind of AI plus AOI solution, right? Or we can start all of this. And in the bottom, you can see the some initial initial example from our team discussion. What is the performance matrix or index looks like, right? So you can see we might include the force core escape component count per hour CPH, and the metrology MSA, and system robustness, right? Reliability, support capability, programming optimization, and duration time, things like that. So it's just a list right here, and from the actual project execution, we might just pick some most commonly interested by the team members. So we focus on those index accordingly for the actual project execution. Yeah. Haley. Okay. Yeah. So this is just to explain because we are involving the AI, right? The AI concept and steps into this project and the process. So we want to make sure the team understand what we are going to use in terms of the utilization of the AI technique, right? So let's look at the overall life cycle, right? For involving the AI into the process. So how should I say that? Okay, so typically, let's look at the red box in the top, right? So as you mentioned, the statement here, the top red box is not in this project scope. We want the team to understand this clearly, right? So because this red box defines how we generate the AI model, including how we train the AI model, right? So that means typically for the AI model training, right, we might need a lot of training images. So we have example, maybe you need 100,000 or maybe around that kind of scale, right, in terms of the image quantity, and that is really a challenge for the industry, right? If you look at your image repository in your production, can you have that kind of sufficient image quantity on hand, right? And also, what is the AI framework you're going to use? There's a lot of mature AI framework and technology in place. It's like TensorFlow, Caffe, PyTorch. I just give some example, right? And And this is the relevance and factors for you to train the AI model and to give the optimization on the AI model results, right? And on all after this, right? So we get a so-called trained AI model, which is at the bottom of this red box. So this trained AI model will be input to our project here, right? But for the red color here, all this what we assume is in place, readily available from some of our player, right? So we are going to touch the training section of this AI part, right? So we assume this is available, and some maybe the machine supplier, the AI solution company, they have this kind of capability in place. So this is the assumption of this project, okay? And if you look at the bottom, the blue box here, right? This is within our project scope, right? So we start from the test vehicle. So as I just explained, we have some I call the force defects, right? So we force generate some kind of defects on the test vehicle by certain manner, right? This will be discussed in the project as well, how we are going to form these defects on the test vehicle, and then this test vehicle will from the experiments phase, we will input this test vehicle into the AOI, right? So the AOI so that the AOI can generate the reject images, right? For our experiment one. So this new image will be sent to this AI model, which I mentioned in the red box in the top, right? So this trained AI model will help us to classify this new image. We call the inference process from the AI model, right? So from this inference or classification process, we can see the output from the AI model, whether it's a good, it's a false call, or whatever result, right? We can get from there. So this is within our project scope. So in a short sentence, right? So we want the team understand what we are going to cover and what is not, right? So by this chart. So hopefully this is easy to understand, right? Okay.
Okay. I think in next several slides we will have Philip to discuss. Okay. Philip, are you there?
Oh yeah. Okay, so thank you, Wayne. Okay, so in this part, let me give you a brief overview about the project focus, which is and is not. So this is what Wayne just explained a while ago. So you see the first part. So this project focus on both combined technologies of AOI and AI. So this is the main focus. So we don't focus on the AI development algorithm alone. No, so we will not cover this. We assume that this is already available, and then it will be combined to the AOI, and we will characterize it. No? So that's the first one. Second, so this project mainly focus on PCBA, so on the board assembly classified defects, and we will not touch for the bare PCBA or bare substrate or in a package level. Okay, and then third, so this will be done, yeah, as explained by Wayne. So there is a test vehicle that we will be developing. Okay, so this is either be donated. We will produce this test vehicle. No? Basically, on the other side, we will not get samples from any suppliers or any product, so to avoid the bias when we do the process characterization. And then the fourth one, yeah, it's anonymous evaluation. No? This is a process characterization that we will be doing, and then yeah, we will not create any development standards on here. We just want to understand what will be the response of these two combined technologies, and we want to at least utilize it in order to adapt the predictive analysis in order to improve the AOI capability. And at the same time, this will also at least reduce the involvement of the operator. So basically, we want to reduce that involvement. Though in the diagram of Wayne, yes, there is an operator, but as much as we can, we want to limit the involvement of operators. And lastly, we will establish common language. Okay, so this is the common response metrics, no, from these two technologies. And this is not a development of AI solution. So that's the project focus. Can you go to the next slide? Okay. So for the project tasks and estimated schedule, there are two phases, no, with a total of 20 months to complete it, and the timeline starts from the day if you sign up and the participating team members confirm. So you see in the phase one, this is the investigation and planning. So we have 6 milestones. We have communicate and survey. And then, initially we already finished some of this and established AOI and AI workflow. Third, categorizing the PCBA defects for AOI. So we did some survey from different EMS to understand what are the major top defects they're encountering in AOI, especially the false calls. And then fourth, define performance metrics, and we will develop the experiment plan, and we will prepare the test vehicles. So that's the phase one milestone. And the second phase, so this is mainly focusing on experiment execution. Get ready with the test vehicles. And second, solidify experiment schedule. And third, we set up the AI capability experiment. No? So we will be identifying um, from the team that will be participating where we can perform the experiment. And we will run the experiments, and fifth, we will collect AOI and AI performance data, and we will do the analysis, brainstorming, and we will finalize our summary and recommendation. So that's the milestone for the phase two. Okay, and then this is the benefits, no, of the participation. So we do really encourage you to please participate in this very good project related to the smart manufacturing. Well, first, you will have an advanced understanding of the current capability of AOI and AI solutions in the industry. So you will be part of the working team in defining the future AI solution scenarios to improve the AOI process. And second, by working together with different EMS and OEM, the AOI equipment vendors would for sure achieve better understanding how to evaluate or characterize and how to apply AI technology for their existing AOI solutions. And then lastly, to increase the inspection efficiency and accuracy and reducing human resources required for manual inspection, verification, and mitigating defect escape risk. So this is also defining common language and performance evaluation metrics would help accelerating the technology development and adoption. So these are the benefits if you decided to participate and join us in this project.
Okay.
I think that's all, Haley. Thank you.
Yep. Thank you, Philip. Thank you, Wei, to introduce the project. So I will spend several minutes just to explain how to join. So first of all, we have a web page set up for this project. It's on the iNEMI website. You can download the project SOW and the project statement, review those documents, and for the iNEMI members, you can just go ahead, if you decide to join, go ahead to sign and submit the project statement. And for the non-members, as I mentioned earlier, phase one, it will be a fast turnaround project. to investigate and to develop the plan as mentioned. But for phase 2, since we have resource commitment, I mean, more experimental resource commitment and also more detailed work on to carry out those experiments, to do the evaluation, etc. So that part we will certainly require the membership for iNEMI. For the non-members, if they want to join the phase 1, certainly they can decide if they want to continue with the second phase to join the membership. Okay. So this provided a chance for the iNEMI members to get involved. But this is limited only to one iNEMI project. Okay. So for the MOU and the non-member participation, for those who are interested, you can contact me directly, and we can have some communication there.
就是因那边也有做3C863加跟862H分家的。
No question. Right. Okay. So I will be the facilitator for this project. So if you have any question regarding this project or this sign up about joining, you can contact me. Let me, before we go to the Q&A, let me show you the. I think some people is talking. Okay, let me briefly show you the project statement. I hope you can see this Word document. You can download from the iNEMI website. So the content here, so we have the participating member. It's the name of the company. For example, IBM or AMI or whatever your company name is, if you decide to join. So we have the iNEMI bylaws, those terms for the participating agreement, this IP policy. So this is the legal term that we need to comply with. And if there are background technology, you can choose. If you have that, you will disclose in conjunction with this project, or if it's not anything mandatory, right? You can decide by yourself if you intend to share anything of your background technology or IP, you need to declare. Okay. Then with for this project sign up, it's a 2-step. So first, we have 2 signatures required from the company participants. Then need approval from the management to acknowledge the support, the contributions, commitments defined in this document. Right? Then for the following section, just to describe the resource, man hours, and about the data management. So we require the companies who are going to join the project to regularly participate in the project meetings, to carry out some of the tasks as agreed. And also for this project, phase 1, we don't expect that there will be any expense. But for second phase, it depends on the experiment plan, if we build a test vehicle by ourselves or if we can collect donations. So that part, we will update this project statement for the second phase. So here it's only for the phase 1. So phase 1, we don't have any monetary expense expected. Okay. So just in case there is any expense may incur, then that will be shared and approved by the participating members in advance. So it's basically the project is owned by the whole project team. So they make the decision and they decide together what need to be done and how to split the cost. And sometimes for the iNEMI project, there are maybe institutes or universities from the academia, they participate. So we typically, they are the affiliated organizations. That's a type of members in the iNEMI membership. They will exempt for the expense. So here, just to emphasize, we will adhere to the IP policy and regarding the IP or the disclosing background technology information. Okay. So for the data and the information developed by the project, as said, it's owned by the whole project team. So the project participants need to classify the data and decide the role, how to manage the accessibility and the data reporting. As we mentioned, typically at the end of the project, we have a webinar or have some results or report will be published to communicate with the industry and to help with the result deployment. But the core or the raw data is owned by the project team. They make the decision on what to share and what to be communicated and in what way to do that. Okay. So yeah, as iNEMI members, they will receive the status reports and some summary reports. So this is decided by the project team. Okay. And also, if there are some information will be communicated outside or published outside the project team, those information need to be agreed by the project team, get approved by the project team to before it's shared or communicated outside. So typically after a project is accomplished, when the project team is dismissed, this management of data will be transferred to the iNEMI secretariat. So that's make sure that the roles for the data is data management is carried on. Okay, even after the project team is dismissed. Okay, that's basically what we have in this project statement. We will have the signature page for the participants. If there are multiple people from one company who join the project, you don't need everyone to sign this paper. Only one person just sign it on behalf of the participants. You can let me know the who will be involved in this project. So we will have a manager distribution list to make sure all the others are invited. Okay. So then the second signature, as mentioned, it's also from the participating company. Need their management approval to make sure the task or the contributions they are going to provide to the contribute to the project are supported by their management. After you finish the above signature, you can send the copy, scanned copy to us. Then from the iNEMI side, we have Grace O'Malley. She's a VP of Technical and Project Operations. She will review and give the acceptance approval for the participation. I just briefly introduce the project statement. I think for the project SOW, the major content is already introduced by Wei and Philip. I will not go through the details. You can download from the project web page. So with that, I think I will stop and open the floor for discussion. So any questions? So you can unmute yourself, or you can use the chat. Let me see if anyone. Okay. Anyone has the questions to the project?
Hello.
Yeah.
So I want to check, will you share this document to us after this meeting? So it will be easy for us now to download from your website.
The presentation, in fact, we have another staff to distribute this recording, etc. And so typically she will just distribute this presentation and recording. So if you have any issue to get the document, you can just contact me. I will send out to you guys.
Okay.
Is that Robin?
No, this is Rick from Sastica.
Oh, okay. Okay.
Okay.
I will send you later. Okay. I think I have your contact.
Yeah, thank you.
Okay, any other questions? Any questions to the projects about the participation, the scope?
So Haley, this is Mark. I may have missed it. Is there a tentative start date for this?
Oh,
Do we know?
I do. Thank you for reminding me. I forgot to mention we have the Standup Due Dates defined by the end of this month.
Okay.
So we
hopefully
hope, hopefully we can start the project in in November, the beginning of November.
Yeah, so Haley, this wing. So I just want to share, right? So this project is currently under the board assembly tick and the smart manufacturing tick, right? Both.
Yeah.
Okay. Yeah.
Yeah, it's open for all the iNEMI members, and as I said, it's relatively open for non-members as well. Yeah, but there are some terms need to be agreed upon.
Excuse me. So
Yep.
we have 2D and 3D AI in the market, right? So is this project focused on 2D or 3D or both?
Where you want to answer?
Yeah, this might be a good question. So at our initial discussion, we primarily focus on the 2D, right? 2D images, but this technique can be also covered for the 3D section. So I think this is a good question we need to consider highly. Yeah.
Yeah, I think in the project, especially the phase 1, that's why we have this investigation and planning. We want to have confirm the team to define exactly the experiment plan, etc. So that's something. Even we, as Philip mentioned, we did some preliminary survey and communication, but all the we results and we need to be confirmed and reviewed again. So that's why we have this phase really to.
Can I also add, Heidi? Yeah. Initially, we want to design it because it's another station. It's an AI. It's an integrated, a separate station. So this solution might be common to both 2D and 3D AOI. So that's initially we want to design this evaluation because majority now are using 3D AOI.
Yeah.
Okay.
Yeah, and I think also we need to consider the need, right? So for the 3D, I don't know whether the performance, like the force call is better than 2D. I don't know. So this also depends on the need from our industry, right? So what to focus more? Yeah.
Yeah, I think 3D is the future because most of the company will be replaced that 2D equipment by the 3D. And
Yeah.
3D have a better for score data and escapability, and
Yeah.
also easy for the AI, I think.
Yeah.
Because he can provide a very exact date we have, not like the 2D.
Yeah, correct. Our initial survey, we have majority 3D data, and we also have 2D data. So, yeah, I think we can cover that. So, we'll answer you, Rick, on your question.
Another thing in my experience, we have too many for score come from the OCV, which we use to check the body mark of the component. So that will be maybe an important thing which you consider about by using the AI equipment. Oh, sorry, use the AI technology. The OCV.
Yeah. Yeah. So that's a good input, right? So one of our survey effort is to understand what is the top defects, right, from your AOI production, right? As you mentioned, the body marking seems to be a common challenge in some of our defects. So this will be one of the focus. That's why we put the body marking image in the slide 7, right? Can you jump to slide 7? Yeah, we put some example image there, right? So the third picture here is for body marking, right? So we understand this would be a common challenge in the industry. Yeah. So hopefully we can get some some defects in our test vehicle for this reason. Yeah.
Okay. Yeah, no question for me.
Okay. Any other people?
This
Yeah.
is I have
Go
a
ahead.
question on the process. What's the process for deciding who is going to do what upon concluding the team members?
Okay, so for the phase 1, it's it's more like a investigation and planning. So it's more like a discussion, and jointly we discuss the survey and maybe conduct the survey, do some analysis together to decide the plan. So, but for the second phase, we don't have now in this project statement the resource plan. I mean, the details. For example, who is going to probably donate to the test vehicle, or who is going to do some assembly if we want to fabricate some test vehicles, and who is going to carry out the experiment, where to do that. Even in this schedule, as you see, we just showed the 2 rounds of the experiment sites. If we have multiple sites, maybe we have to do it, sequentially, use the identical test vehicles. So all those we need to, we will have a more detailed resource plan, resource metrics. When the phase 2 sign-up starts, we will have the participating members to indicate which resource that they may be able to contribute. So after we consolidate all the inputs, then we will review all together and discuss where and who will do what. It's similarly as the other iNEMI projects. Sometimes we have multiple sites, multiple members they want to contribute to certain tasks. But we do have some cases, some tasks need to be outsourced. So that's need to be discussed and decided in the second phase commitment. But here, I think in phase 1, we will identify the possible, the willingness for the resource or support commitment. to carry out, to gain some confidence that we know that the second phase will be accomplished, achieve the goals as well.
All right, thanks.
Okay. Okay. Any other questions?
Hello.
Yeah.
Yes, I have a question here. So we know that there's a lot of AOIs available in the industry, right? And all of them actually equipped with different kind of camera as well as the lightings, and all these will produce different kind of output images, right? So I would like to understand how this project could generalize those differences or variances in the images itself.
Yeah, I think this is something we discussed, right? You want to comment on that?
Yeah. So yeah, this is a good question, and I think as I would say a key step is that as I mentioned, the input to the AI model is basically the image, right? The image. So as you mentioned, image will be impacted by the the lighting setting, the color, things like that, right? And your algorithm, right? So I think to standardize this process, we just going to collect the image format data as the input to the AI. So hopefully this can reduce the complexity from different solutions. I'm not sure whether I answered your question. Yeah.
Yeah. I think also from the TC review, there are some feedback about the set up the AI model with existing equipment at the test site. So this is something we also need to to do some preliminary preparation to demonstrate if there are some issues come up with because there are different equipment and the interface for the communication for the AI model is existing equipment. That's another aspect we need to work on.
Okay, noted. Thanks.
Yeah, thank you. Yeah, good question, I think. Yeah.
Okay, any other questions? So I think if you think of any other questions later, you can certainly communicate with me, send me an email. For some of them, I may pass to the chairs to answer if that's a technical portion of the project. Okay. Any other questions before we end today's webinar? See? Okay, there is no further inputs to the chat. Okay, I think with that, I would like to thank you all for joining today's webinar, and I look forward to work with you. And thank you, Wei and Philip, to share the project, and we'll take the leadership on this.
Yeah, look forward to meeting
you.
you. Yeah, thank you.
Okay, thank you. Bye.
Everyone.
Thank you. Bye-bye.
Thank you.
Bye.
Good night, good day, good morning.